Hi everyone, welcome to our video lesson on section 7.7 dealing with hyperbolic functions. In this set of videos, we're going to be defining and developing properties for the hyperbolic functions, and then we're going to be taking a look at the derivatives and integrals for these hyperbolic functions. Hi everyone, welcome to our video lesson on section 7.7 dealing with hyperbolic functions. In this set of videos, we're going to be defining and developing properties for the hyperbolic functions, and then we're going to be taking a look at the derivatives and integrals for these hyperbolic functions. Now, the hyperbolic functions will also have inverses, and the inverse hyperbolic functions are the arc hyperbolic sine, sinh inverse of x, sometimes called a sinh or arc sinh, and so on. Now let's take a look at the way that these hyperbolic functions are defined. As we will see, they will share a lot of similar properties to their trigonometric counterparts, but as we can see, they will not be trigonometric functions and instead will be defined in terms of exponential functions. Now let's begin with the definition of the hyperbolic sine. Here we have the sinh of x defined as e to the x minus e to the negative x divided by 2. In contrast, the hyperbolic cosine, cosh, is defined as e to the x plus an e to the negative x divided by 2. Now, with the other hyperbolic functions, we get to see some of the properties that are similar to the trigonometric functions. We take a look here at the hyperbolic tangent, tangent of x, and we see that it is defined as the hyperbolic sine divided by the hyperbolic cosine. Now, we can go ahead and define the hyperbolic tangent also in terms of exponential functions. We have here that the hyperbolic sine is e to the x minus e to the negative x divided by 2. Now, once we divide this one here by the hyperbolic cosine, e to the x plus e to the negative x divided by 2, we get to see here that we can cancel the division by 2, so that's gone, and we're left with the hyperbolic tangent in terms of only exponential functions. Here we have it defined as e to the x minus e to the negative x divided by e to the x plus e to the negative x. Now, we have here also the hyperbolic cotangent, or cotang of x, defined here as the cosh over the sinh, which we can also rewrite in terms of exponential functions as e to the x plus e to the negative x divided by e to the x minus e to the negative x. Now we also have here the hyperbolic cosecant, pronounced sometimes as cosec of x or cosec of x, defined here as 1 over the sinh, which we can also rewrite in terms of exponential functions as 2 over e to the x minus e to the negative x. And lastly, the hyperbolic secant, pronounced sech or sech, and it's defined here as 2 over e to the x plus e to the negative x. So here we have our 6 hyperbolic functions defined in terms of other hyperbolic functions or in terms of exponential functions. Now let's take a look at some problems where we get to practice evaluating these hyperbolic functions. And let's begin here with the first example where we have the sinh of -1. Now, using the definition of the hyperbolic sine, we have here that the sinh of -1 is the same thing as e to the -1 minus an e raised to the -1 divided by 2, which in turn will give us e to the -1 minus e to the 1 all over 2. Now at this point, we can go ahead and simplify by recognizing that e to the -1 could be rewritten as 1 over e minus e all over 2. Now, rewriting the numerator in terms of a single fraction, we obtain 1 minus e squared divided by e all over 2, which we can go ahead and finally rewrite as 1 minus e squared all over 2e. And there we go. There is no need to plug this one here into our calculator. We'll leave the exact answer, which is 1 minus e squared all over 2e. Now let's go ahead and take a look at the second problem here when we're asked to evaluate what is the hyperbolic tangent of the ln of 2. Now, using a very similar approach to the one that we just did, I'm going to go ahead and write the hyperbolic tangent in terms of its exponentials, and it's going to be e raised to the ln of 2 minus e raised to the negative ln of 2 all over e to the ln of 2 plus e to the negative ln of 2. Now at this point, I want you guys to remember a couple of properties dealing with exponential functions and logarithms. Namely the fact that, as we know, exponentials and logarithms, they are inverse of each other. So if we have e to the ln of x, we know that we will be getting x. Now the other property that I want you to remember is now dealing with the properties of logarithms, or the laws of logarithms. If we have negative ln of 2, well, we know that we can go ahead and rewrite this one as the ln of 2 raised to the negative 1, where we're using the property that if we have the log of a variable raised to a power, or anything raised to a power, well, we know that we can bring the power to the front and turn it to a product, which would give us p times the ln of x. So, with these properties in mind, we can go ahead and simplify our problem here, which will give us e to the ln of 2 is equals to 2, plus, now in this one here, I'll take an in-between step, sorry, that's a minus the ln of, whoops, sorry guys, e to the ln of 2 to the negative 1 all over 2 plus e to the ln of 2 to the negative 1. Simplifying this further, we obtain 2 minus 2 to the negative 1 all over 2 plus 2 to the negative 1. Now we're dealing with a reciprocal, so we're going to have 2 minus 1/2 all over 2 plus 1/2. Simplifying this further, we're going to have 2 minus 1/2 giving us 3/2 divided by 5/2. Canceling our denominators here, we're going to be obtaining our final result of, oops, it looks like I ran out of space. And there we go, giving us the final result of 3/5. And there we go. Nice problem here where we were using the properties of exponentials and the properties of logarithms. All right, so now let's go ahead and practice with problems involving hyperbolic trigonometry. Let's see if we can go ahead and simplify the following. We have the hyperbolic cosine squared of t minus the hyperbolic sine squared of t. So what would we get? Now for this example, I'm going to go ahead and revert back to the definition of the hyperbolic cosine and the hyperbolic sine in terms of exponential functions. So we're going to have here the hyperbolic cosine, cosh, defined here as e to the t plus e to the negative t all over 2 squared minus e to the t minus e to the negative t all over 2 squared. So let's see what we get from that. Now, I'll let you guys practice if you guys want to get a head start here. So in this case, remember, whenever we're squaring something, we are multiplying it by itself, which, I guess I'll do it here. We're going to have e to the t plus e to the negative t all over 2 times e to the t plus e to the negative t all over 2 minus e to the t minus e to the negative t all over 2 times e to the t minus e to the negative t all over 2. Okay, so as it stands, it seems a little bit of a doozy, but let's go ahead and distribute to see what we get. Focusing here on the first term, applying the surety property, we're going to get e to the t times e to the t, which is the same thing as e to the 2t, plus e to the t times e to the negative t, which is going to give us e to the 0, plus, well, let's see, multiplying e to the negative t, distributing it here, it's going to be plus e to the t times e to the negative t, which gives us another e to the 0, plus e to the negative t times e to the negative t, which gives us an e to the negative 2t. And the whole thing here is being divided by 4. Now focusing on the other term, we're going to have here a minus. Let's see what we're going to get. E to the t times e to the t, giving us another e to the 2t. Then we're going to have an e to the t times a negative e to the negative t, which will give us a negative e to the 0. Now at this point, before we forget, let's go ahead and include parentheses. Now let's continue with our multiplication. Now we have a negative e to the negative t times an e to the t, which is giving us another e to the 0. And lastly, negative e to the negative t times e to the negative t, which will give us a positive e to the negative 2t. And everything was divided by 4. Okay, now simplifying everything here, we're going to have e to the 2t plus 2 plus e to the negative 2t divided by 4. And now, for the second fraction here, distributing the negatives to everything and simplifying, we're going to have a negative e to the 2t plus 2 minus e to the negative 2t divided by 4. Now I distribute the negative already here, so I'm going to put an addition here for the two fractions. So we get to see here that a couple of things will cancel. We have an e to the 2t plus a negative e to the 2t. Then we also have an e to the negative 2t minus an e to the negative 2t. So all the exponential cancels, and then we're left with the addition 2/4 plus 2/4, which gives us 4/4, which gives us here a 1. So this is our first identity, and is closely related to the well-known Pythagorean identity for circular trigonometry, which states that sine squared of x plus cosine squared of x is equals to 1. Similarly, the coordinates cosine of x, sine of x create a circle with a radius of 1, satisfying the equation x squared plus y squared is equals to 1. Now on the other hand, the coordinates cos of x and sinh of x form a right half of an equilateral hyperbola, which can be represented by the equation x squared minus y squared is equals to 1. Now these are just some of the many similarities that exist between hyperbolic trigonometry and circular trigonometry. We will be taking a look at a couple more similarities later on in this video. Now here are some of the hyperbolic identities. Now as you can see, they are very analogous to their trigonometric counterparts. Now the only formulas that I will be asking you guys to memorize is the equivalent of the Pythagorean identity, the one that we just derived. The cos squared minus the sinh squared of x is equals to 1. All the other ones here, well, maybe this one's, which again, very similar to the Pythagorean identities, but with this ones here could easily be derived from the main one. The cos squared of x minus sinh squared of x is equals to 1. The other ones here, if you were to need to use them on an exam, things like that, I will be providing them for you. Now let's get to practice with deriving or verifying some of these hyperbolic identities. And let's begin here with example 3, where we have the identity cos of x minus y is equals to cos of x times cos of y minus sinh of x times sinh of y. So let's see if we can go ahead and verify this one. Now, just as we were doing the examples above, where we converted to the exponential form of the hyperbolic functions, we're going to do the same here. Now let's go ahead and begin with the left-hand side, where we have the cos of x minus y. Well, rewriting this one here in terms of exponentials, we're going to have e to the x minus y plus e to the negative x minus y all over 2. Now this should be equals to the cos of x, which is e to the x plus e to the negative x all over 2 times the cos of y. So we get e to the y plus e to the negative y all over 2 minus the sinh of x, which is, parentheses, e to the x minus e to the negative x all over 2 times the sinh of y, which is e to the y minus e to the negative y all over 2. Now for this one here, guys, I would recommend pausing the video so you guys could go ahead and attempt to simplify this problem, see what you guys get, and then verify your answer. So I'll give you guys a moment to pause here, and I will be providing the answer. Okay, so this is what I got after distributing. So now let's see if there are any terms that cancel out. I see a positive e to the x plus y and a negative e to the x plus y. I also see a negative e to the negative x plus y, which is added here to a positive. And I also see a couple of like terms here, namely with the e to the x minus y and e to the negative times x minus y. So grouping them together, we would get a 2 e to the x minus y plus 2 times e to the negative x minus y divided by 4, which we can go ahead and see that this will simplify. Cancel, cancel, cancel. So our final result will be e to the x minus y plus e raised to the negative times x minus y, which is exactly what we're trying to show. And there we go. We verify the identity. Okay, so this is it for the introduction to the hyperbolic functions, and in the next video, we're going to be delving into the calculus topics, and we'll take a look here at their derivatives and integrals. I'll see you there.